Now we will discuss about the molecules. Molecules. A molecule is the smallest particle of a substance which has the properties of that substance and can exist in the free state. Molecule is a smallest particle of substance which has all the properties of that substance, has all properties of that substance and can exist freely in environment. Just example, hydrogen. It is the atom of hydrogen. It cannot exist freely in environment. It attach with another atom of hydrogen and form H, single bond H, means H2. It means this is the smallest particle of substance that can exist freely in environment. And in the same way, H plus Cl gives HCl, and this is the smallest particle of hydrogen chloride which can exist in free state. Atom of hydrogen can't exist in free state and atom of chlorine can't exist in free state, but the molecule of HCl can exist in free state. Now we will discuss about the calculation of molecular masses. Calculation of molecular masses. As we know, mass of one molecule of substance is equal to total masses of atoms that are present in one molecule of substance. Example, mass of one molecule of sulfuric acid, means H2SO4, is equal to mass of 2 atom of hydrogen plus mass of 1 atom of sulfur plus mass of 4 atoms of oxygen. As we know, the mass of 1 atom of hydrogen is 1, so mass of 2 atom of hydrogen is 2 into 1, plus mass of 1 atom of sulfur is 32, and here 1 atom of sulfur present in H2SO4 molecule, so we can write 32 into 1. Here 4 atoms of oxygen present in H2SO4 molecule, and the mass of 1 atom of oxygen is 16, so we can write 16 into 4. and it will be 98 AMU. If we write AMU, it means it denotes mass of one molecule of H2SO4. If we write only 98, then it denotes only relative molecular mass of H2SO4. And if we use gram as a unit, means 98 gram, then it means it represents gram molecular mass of H2SO4, means mass of 1 mole molecule of H2SO4, and this is mass of only 1 molecule of H2SO4, and this is mass of 1 mole molecules. 1 mole molecules means Na molecules. Na molecules, and Na means 6.022 into 10 to the power 23 molecules. So we can say that 98 represent relative molecular mass of H2SO4, 98 AMU represent absolute molecular mass of H2SO4, means mass of one molecule of H2SO4, and 98 gram represent GMM, means gram molecular mass, and it represents mass of 1 mole molecules or Na molecules, or we can say that 6.022 into 10 to the power 23 molecules. Phosphate Ca3PO4 whole twice. This is not a molecule, this is a formula unit of calcium phosphate. As we know, calcium phosphate is an ionic compound, so it is consist of ion, not consist of molecules. So now we can calculate formula unit mass of calcium phosphate. As we know, here 3 atoms of calcium present in calcium phosphate, so the formula unit mass of calcium phosphate is equal to mass of 3 atoms of calcium plus mass of, here 2 phosphorus atom present in calcium phosphate. Now we can say that mass of 2 atoms of phosphorus plus here 4 into 2 8 atoms of oxygen present in calcium phosphate, so we can write mass of 8 atoms of oxygen, and we know mass of 1 atom of calcium is 40, so we can write 40 into 3, and this is the total mass of calcium in one molecule of calcium phosphate. As we know, the mass of phosphorus is 31. Now here 2 atoms of phosphorus present here, so we can write 31 into 2 plus mass of one oxygen atom is 16, and we can multiply it by 8 because here 8 atoms of oxygen present in calcium phosphate, and it will be 310. If we write 310, then this is the mass, this is the relative atomic mass of calcium phosphate. As we write 310 AMU, then it is the absolute molecular mass of calcium phosphate, or formula unit mass of calcium phosphate, because we can consider CH3PO4 whole twice as a molecule of calcium phosphate, but in fact it is a formula unit of calcium phosphate. And 310 gram will be a gram molecular mass or gram formula unit mass of calcium phosphate.